So hey, my name is Jan. I'm from this company called Palantir. How are you guys doing today? Good? Yeah? All right. Yeah, well, good morning, happy Friday, yeah. All right, as an introduction, let's talk a little bit about the company. So about us, Palantir, we're about an 1,800 person company. We're based over in Palo Alto, just like a 20-minute drive in that direction. We have offices all around the world. In one sentence, the thing that we do is we make products for human-driven analysis of real-world data. I work for a team that manages the build and release. Okay, so responsible for tooling. Gradle is one of these things. And for the build and release systems, these include things like CI, SCM, artifacting. The team name is called Rainbow, of all things. And Rainbow is an acronym. It stands for Release Automation Infrastructure in Builds or Whatever. With much emphasis on the whatever part. We do a lot of different things. All right, cool. So the current state of open source at Palantir is that we're looking to open source more things. Right now we have a variety of different things that we have on open source. Palantir at github.io. We're getting more into it. Last year, I think we literally had like all of 8 projects, a couple of Eclipse helpers, and this thing called a TypeScript linter. And this year, like right now, I counted this morning, we have 40 different repos. So I'd say that's a pretty major increase from 8 to 40. So yeah, we're definitely looking to get more into open sourcing. As you guys probably know, open sourcing has a lot of benefits. It's great PR. It's good corporate karma. And you get contributions. If you ever want anything to be like an industry standard, you definitely want it to be open sourced. So we're definitely looking to get more into this space. So I'd like to discuss 3 development scenarios for what happens when you do open sourcing. So the first scenario is called external. This is where you essentially do all your development on, say, GitHub or Gitorious, or choose your hosting solution, and then you do your builds in something like Travis CI or CloudBees, and you essentially pull dependencies from the internet, from Maven Central, Bintray. This makes your life easy. If you're the guy responsible for open source, your job is pretty much done. All you have to do is go up to legal and say, are you guys cool with me open sourcing this thing? And when you get the go ahead, then all I have to do is click a couple buttons in GitHub, and all of a sudden your thing is open sourced. So this is the easiest absolute case for open sourcing something, which is that your work's already been pretty much done for you. That'd be freaking awesome, yeah. The thing here is most development at our company is internal, where we have a lot of internal dependencies. A lot of times we make a big product, like we have a couple of 100 sub-project builds, and we realize, hey, this one component, this database layer, this widget, this automation framework could potentially be open source, but guess what? It's stuck into a much bigger repo, and you have a lot of work cut out for you. And I like to mention that for the external case, I mean, open source, that should say is open sourcing is actually supposed to be like the thing you're supposed to go for, and here in internal, it's supposed to be an afterthought. So that's kind of a typo on the slide. In order to get from internal to external development, we have this approach called, well, basically hybrid. You have some internal dependencies. Most development happens internally, where you essentially use your CI tools, you use your SCM tools, and the agreement here is open sourcing is the eventual goal. So a lot of these projects are smaller, like instead of the massive multi-hundred sub-project projects in which you can eventually open source something, most of these hybrid projects are like a single project that's eventual goal is to be open sourced. So in the external development case, you have your source code, you have your CI, releasing, and of course artifacting, and you can just use openly available tools. GitHub, Travis CI, GitHub releases, and Bintray. So the tools are already out there, and in many cases you can do this for free. Like you literally have to make no investment in terms of capital in order to use these tools here. One of the examples that Palantir is developing on right now is called Plottable. Plottable is a JavaScript graphing library on top of D3. It is completely externally developed, as in our developers use GitHub, they use Travis CI, and they publish it to Bintray. The exact opposite case is internal development. So here we have our source code, CI, and artifacting. And the takeaway from this is that it actually makes a very tight loop, where the source code gets built, it gets artifacted in other products. Other code bases consume it from the artifact layer. So this is a very tight loop, and it needs to iterate very quickly. And there's a mixture of things that can or can't be open sourced. And so externally doing this loop is actually not really an option. And breaking things out of this loop is kind of difficult. In addition, we have packaging. You need to make it into some kind of consumable artifact for the customers, some kind of installer, some kind of tarball. QE does a lot of testing. We need to make sure we have a blessed version. This is more of your traditional release cycle. And releasing. At our company, we don't really have just one deployment. We don't have just one website. We have a couple of 100 deployments, and each of these has their own scenario. Some of these deployments are on the cloud, and some of these use their own servers. Some of these deployments are air-gapped. So the releasing is completely non-trivial in this case. So as a comparison of the tool chain we use for internal and external development, this is what it kind of looks like. SCM, we use both Garrett and Stash internally. Externally, there's GitHub. Internally, for CI, there's both Jenkins and Bamboo. Bamboo is a lot better for the more complicated builds, and Jenkins is a lot better for verification. And externally is Travis CI. Text is awfully small here. In order to do releases, we have this thing called Almanac. It's an internally developed tool, which is the correlation externally is GitHub releases, and artifacting, HTTPD, Artifactory, and Bintray. So in the hybrid case, we have internal and external, the blue box and the red box. Internally, we have our internal stack, SCM, CI, artifacting, and externally, we have our external tools. So the question is, how do we do this? How do we get our source code from here to GitHub? And how do we accept contributions back to our own code base? Additionally, how do we consume artifacts that have built? Let's say our code built all the way, Travis CI releases in Bintray, how does it get back into here? So Bintray to artifacting, this link is actually fairly easy. We just use Artifactory, and Artifactory has an excellent feature called, it can do remote repositories, or it can just mirror it. You can do a lazy mirror where if you fetch an artifact, it can just cache it locally for you. So we're literally consuming our own artifacts using Bintray, just like external artifacts. So for contributing code to GitHub, the source code needs to change. Internal dependencies like this one, so like we have a plugin that sets all of our repositories, so you don't have to have a giant repositories block. We also, for some projects, have a custom Gradle distribution, which has custom resolvers in it. This can't be published externally. Externally, you get something like that. Additionally, there's versioning. Ideally, you'd want to have some kind of scheme, some kind of relationship between external and internal versions. I mean, how are you going to do this? Is it going to be, say, a mapping? Is it going to be something where you have a list of versions internally with their external mappings? Is it going to be literally the same? Like, is 060 going to be the same as like 060 externally? So there needs to be a plan for this. The binaries need to coincide with their source somehow. Accepting contributions, well, you get tons of merge conflicts, because internal development kind of chugs along at its own pace. Externally, someone makes a contribution to code that's probably like a couple of weeks old, and all of a sudden you have a lot of merge conflicts. So the story built around this is, it's kind of complicated. So the goal here is to make open sourcing a lot easier, to make it accessible to more teams, and to essentially make it so that anyone in Palantir can make their product open source. So there are 4 things to consider when open sourcing. So the first thing is build script. The best practice that we found is it's best to keep the build script mostly consistent between internal and external versions. Your build logic should be mostly the same. So when you make major changes in your build script between internal and external version, that introduces a lot of potential problems. So ideally, we can keep this fairly consistent between internal and external versions. So for that, we have a local plugin proxy. We'll talk a bit more about that in a little bit. Next up is dependencies. So when you have a big code base and you have a nice ecosystem of artifacts in your company, you'd be tempted to use the stuff that your company produces. You know, like you can't fault your developers for using an internal library for their potential open source project because it's available and, you know, why not use it? You need to make very, very special care to make sure that the dependencies can be open sourced or already open source. So ideally, in the most ideal case, you can just use already open source plugins and dependencies, and then you'd be great. But that's not always the case. Like I mentioned, versioning. Versioning, we definitely need to have some kind of consistent scheme. For that, we have a plugin we like to call FlexVer, which is open source, and I'll talk a little bit more about that later. Nothing's a substitute for good planning, though. So before you even begin, you need to make sure that you have a release plan. You need to have a make plan for external contributors. Like, this isn't something that happens overnight. You need to literally think about this before, well before you open source your project, preferably before your project even begins. So let's talk about build script. When you have internal plugins, your build script probably looks like this. Whose build script looks like this? Yeah, a couple people. Yeah, so I mean, in order to consume internal plugins, somewhere in the code, whether it be in init script or the build script itself, you gotta have a block like this. In our case, we have a ton of different patterns for the artifacting or the artifacts in the IV files. Some of this is for legacy reasons. Previously, we published under a certain pattern, then we changed it, and certain people wanted versions in the artifacts, and as a result, we had to put all the patterns in the repository section. And of course, we have our artifactory mirror of Maven Central, so that's what we call third party right there in the middle there. And down here are our internal dependencies. Some of these do publishing, some of these set a bunch of repositories, and essentially these are things that are not completely applicable outside of the company. We want to look more like this, like the shadow plugin. Why does it get special treatment in a plugins closure, and why do we have to have a build script that looks like this? Like, changing from that to that is a major break in build script, and it might cause problems down the line because we change a lot of it and we're open source it. So if we had the option, we could do, say, like the default repositories plugin right there, which injects all the internal resolvers into your project. And we can also have alongside the shadow plugin. And that way, when you go ahead and open source your project, all you really have to do is have a 4-line delta. Delete that line and put it in Maven Central. So that's a lot better than, say, the previous case in which we had to do that to that, which is a major jump. So in order to do this, we have a plugin proxy. So for those of you guys who are using the plugin closure, which has been available since Gradle 2.0, I think, we have a site that's plugins.gradle.org. And whenever you use a plugins closure, it's going to reach out to Gradle. It's going to reach out to the internet, and it's going to pull plugins and the metadata from pluginsgradle.org. So we're proxying that with, again, Artifactory. There's a couple missing pieces here, though. One of these is that there is actually metadata that comes from pluginsgradle.org that's hard coding the M2 repository inside pluginsgradle.org. So for that, we have an Nginx proxy. So Nginx is a module you can do substitution of page content. So we're substituting the link that links directly to Gradle, pluginsgradle.org with just something that links internally. So that's where our local builds can look at Nginx and Artifactory and not pluginsgradle.org. This is a nice side effect of limiting our internet dependencies at build time. This is the kind of JSON you get from pluginsgradle.org. It contains metadata about the plugin, contains a version, contains what looks like a actual module descriptor, and the location from the repository. So what Nginx is doing here is it's changing this link to that. So it's linking from somewhere external to somewhere that's internal. And this is easily done within like a couple of lines of Nginx.
Do you only do this for caching reasons to save external internet access, or is there also a functional difference that you provide some additional plugins in your own artifact repository? Or
Both. Yeah, both. Yeah. Oh, yeah, sorry, repeat the question.
Plugins, this won't work externally if you're not using the same proxy.
Right, exactly. Something like the question was, how do we use this? It was, do we use it for local caching? Do we use it to introduce local dependencies? And so we do a little bit of both. First of all, caching is very nice, you know, like you don't have to reach out to plugins and Gradle to work for every build. And yeah, we also introduce internal dependencies and inject them within here too. So the way that works is there is a option. There is a flag you can pass to Gradle which tells it to use the Nginx proxy for its metadata. And that's actually somewhere buried within Gradle. Good thing that Gradle does include an override so that you can literally pass this in via a wrapper or environment variable or whatever. So that option we tucked into a wrapper, tucked into distribution. So it can be introduced many places, and it can point to an internal, our internal Nginx proxy for the metadata. So this way we can introduce internal dependencies. So let's say we have our repositories plugin. The repositories plugin really isn't applicable to pretty much any build outside of Palantir. Like, it won't work on the internet because they won't have access to local subnet. So that's the reason why we keep it local. And so we put the JSON metadata in Nginx, and we put the actual artifacts in Artifactory. And for the most part, this works so that you can have first-class treatment of your own plugin. So you can do like a plugins closure, and then you can put in things like, say, com.palantir.this plugin, and that just completely works. I mean, so you made a good point, though, which is how do you use these plugins when they're internal? When you open source it, obviously the links are going to be broken, not going to be available. The answer is we have to open source as much as we can. So I mentioned that there were about 40 different projects in the Palantir GitHub repo. The majority of these, I'd say, are actually Gradle plugins. So both our team and our counterpart team that takes care of code quality, we both publish a lot of plugins. So in this case, there's the Flex version plugin that I'm going to talk about in just a second. We have integrations with Bower, with Python, and we also have plugins to do things like pulling in a distribution of Node, npm, and just unzip it and use that instead. So yeah, it's a pretty big impetus to open source pretty much as many plugins as we can. So we keep internal plugins internal, and we open source whatever we can to the external world. So versioning. Versions at our company kind of look like this. You'll notice that it's kind of complicated. So the way this works is via a plugin called Gradle Getsimber. How many of you guys are familiar with semantic versioning? Semantic versioning? Yes, semantic versioning is the standard where you essentially the version number, which 3 digits actually means something. In this case, we made a plugin which looks at your Git history to determine a suitable version number for it. So the 060, that comes from a tag. So it looks at the most, it does a sort of all the tags in history and finds the biggest one and uses that to begin the version. The number 5 here is the commits after the tag. So you tagged 060, and then you make 5 commits on it, and that makes it number 5. And this here is the Git hash. So the benefit of this versioning scheme is that we can publish as many snapshot artifacts as we want to without having to overwrite the original ones, okay? So we essentially publish and keep a local copy or internal copy of pretty much every build that we've ever built, so we don't consistently have to overwrite a snapshot artifact. As you can probably imagine, with a versioning scheme like this, it's kind of hard open source. It's pretty rigid. I mean, like, you have to basically keep the Git history almost entirely, well, you have to keep it entirely the same in order to make it so that the external versions and internal versions match up. So that's something that can always happen. Like, Git history must be, probably is different between internal and external. Like we have to do some cleanup, we have to do some data redaction, we have to make sure that it's suitable for external release. And so the version number, if we use semantic versioning, would probably be different. So we introduced this new thing called flex version. Flex version is called that because it's pretty flexible. It looks at a bunch of different things. First of all, it looks at a master global override. So if you set an environment variable, it says, screw everything in the Git history or local settings, I'm going to use the override. If not, then we look at tags. This is very similar to what Simver used to do. After that's environment. We can declare a couple environment variables in the DSL that tell this plugin what environment variables to look at. And if it finds one of them, it uses that version. If all else fails, then we look at the branch name. This way we can have a branch called 070, 071, and it can use a branch name to figure what the version is. And this is an open source plugin, so there's a GitHub link right there. So typically, in the internal case, we use the branch name for versioning inside the company. So we essentially have a development branch called 070 and a published artifacts that are like 070-number. Externally, we tend to use tags. So the version, say, 060-260, so a little bit of change here from Simver. The middle number actually means the number of commits since the beginning of the repository. And of course, Git hash is also there. Externally, we use tags, and tags basically look like that. So the versioning is fairly consistent between inside and outside. So flex version gives us a nice way of, gives us a lot of options for doing versioning so that we can actually have a system for keeping the internal and external versions kind of at least somewhat similar. So let's talk a little bit about the planning section of things. So let's say that we have that we considered all the technical details about keeping dependencies mostly external, about trying to make sure the build script is relatively consistent between internal and external, and also to make sure the versioning is consistent. Now I have to plan for a number of different things. This probably should come first. So first of all is eligibility. Like, why are you open sourcing this project? Like, what was your original motivation behind open sourcing it? Like, were you hoping to get external contributions? Is it something that you're doing for PR, recruiting? It's going to take someone a lot of work in order to open source some of these projects. So the question is, will the benefits outweigh the costs? So you have to do some serious cost-benefit analysis here in order to figure out whether open source is even worth it. Of course, there's dependencies. You'd probably have to do some significant refactoring to make sure that your internal dependencies are not being used right now. Of course, public API, that goes without saying. And there's a release plan. Like, the release plan here needs to be, you need to have a very concrete plan of when you want to release it. Like open sourcing, if you want to make an open source project, then you need to, how do you keep it, how do you release it? Do you keep it in lockstep? Like, is every single release internally going to be an external release? Do you do open sourcing every month? Like, take whatever code you have every month and open source it? And finally, contributions. Like, how are you going to get them back into the current repository? And right now, it seems that pretty much every different open source project seems to have a different release plan. But that's probably fine, as long as I have a plan. You know, not like just open source this thing and never let it be maintained forever. That's not very good open sourcing. Auditing, Git dig. Git dig is a utility, open source utility that lets you basically grep through all of history in Git. And you can look for different kind of patterns. Like, you can look for something that probably looks like a password, something that looks like an SSH key. And I mean, you need to make sure this stuff doesn't get out in the open. So this is one of the reasons why having good auditing, maybe in the form of like commit hooks, is a really good idea. So for the hybrid development case, as long as these 5 points are kept in mind, and as long as the technical issues are kept to a minimum, it's not really that bad. So the really bad cases are the cases of where we develop something completely internally, like I mentioned, part of a much bigger project, and this bigger project has a lot of internal interdependencies, has a lot of, it's very tightly coupled, and it's very difficult to open source things from within this repository. So let me tell you a story. Atlas DB is a it's a layer on top of a NoSQL database like Cassandra, and introduces transactions to that. So back in the mid-2000s when Palantir first started making products, we use a relational database, and some of our deployments still use relational database. And there are significant problems with scaling with relational. So we chose, why don't we use something like a NoSQL thing, non-relational? Well, the problem is you don't get transactions. So here's a basic architecture diagram of a couple layers sitting on top of a key value store. And Atlas DB essentially is something we're deploying to most deployments now, where we actually can use something like Cassandra or an in-memory key value store for testing, and it provides a great layer of abstraction. So this seems like something that could potentially be open sourced. This seems like it could be something we get a lot of contributions on. So the motivation seems to be that this is something that probably is a good candidate for open sourcing. Yeah, I didn't make this up. You can find it on the internet. If you Google Palantir Atlas DB, you find this exact same arc diagram on the blog. Cool. So the challenges that Atlas DB has for open sourcing are pretty big. Right now it's a pretty integral part of the larger project. Like it's part of the Palantir Gotham repository. It's our very large project, one of the first projects that this company had. And it has dependencies on it, and it has dependencies on other projects. So we have dependencies on things called PT app server, which is literally a modified version of Tomcat. And these are all checked in the same repository. So literally you can't blame developers for using things in the same repository because obviously it's there. Why not use it, right? The build tooling layer is kind of not great either. We right now for building all of the bigger repo that Atlas DB belongs to, we have an internal build tool. As with most, this build tool, it's actually, it had some great intentions. Back in the days of just using Ant, Ant's pretty verbose, and we had an idea about making a build tool that was both declarative and imperative. So you can have imperative code, you can have declarative code, and for a while it worked out, but now we don't really have a plan for maintaining it anymore. We're going to most of the projects at our company use Gradle now. And the original build tool was kind of hard to use as well. So obviously you can't open source when your build tooling is something that's completely internal, and you're not going to open source that either. And for the releasing portion of this, it's actually especially difficult. It's difficult to come up with a plan for something this internal, this tightly coupled with everything else. So if you want to release, what's the source of truth here? Is it the external repo? Is the thing that we're going to put on GitHub going to be the source of truth? Do we pull that back in for builds? Do we build artifacts of Atlas DB on Travis CI, publish to bench array, and consume internally? The answer is everyone seems to have their own opinion here. People want to make it so that they can make a change to the big repo and make changes that are corresponding to Atlas DB as well, and they don't want to have to block on waiting for an open source. They don't want to have to wait for an open source release. So that brings the question of versioning. Our internal versions, how do they map to external versions? Obviously, you would probably want something separate like Atlas DB to have a different version than the internal product, right? But the problem here is how do you make that relationship? How do you make that dependency? Do you use plus dependency? That's not great practice. So the answers we came upon so far are, well, there's no substitute for just diligent refactoring part of the devs. I think we've probably, we had someone working on this for the past couple months now. We're open sourcing our dependencies. We're seriously open sourcing a lot of the things in this big repo that Atlas DB is in. And the thing we find that works the best is literally to extract out the different projects. Atlas DB is 5 or probably maybe a 10 or a dozen sub-projects in this bigger repo. So extracting all those out into a subtree that can build itself, it's very helpful. For the build tooling, it's going to be converted to Gradle. The thing is, how do you have, would you really want to have 2 build tools in the same repository doing different parts of the build? And the answer is people typically don't like this very much. The other thing is we can't convert to Gradle in one go either. It's going to take someone probably about maybe a man-month, at least a couple weeks, convert all of the big repo into Gradle. We can't just say stop development and wait for conversion. Also, making a fork of it or making a branch of it and converting it to Gradle is a little bit harder too because of the pace of development, constantly changing dependencies. So one of our engineers made a thing called meta build. Meta build is actually written in Python. It has a template for Gradle projects where it takes the template and applies it to a list of the projects that you have in your repository. So that it generates both a Gradle build and a buildlib build. So you can actually have both. This way we have an intermediate step so you don't have to basically say all or nothing. And releasing is still kind of TBD, you know. Last time I checked, AtlasDB wasn't on our GitHub page just yet, but we're hopefully going to be releasing it soon. And to go back to the planning section of this, all of this happened within the course of several years. I think the original decision to open source AtlasDB happened back in 2013. Back then it was a very obvious win. You know, like we can open source this thing, become hopefully, it can be something that people can help us contribute on, maybe even become an industry standard. Things have changed in the last 2 years. And given the amount of work we put in open sourcing this, it's not exactly nearly as defined as to what the benefits actually are of open sourcing this. So things changed. And one of the takeaways from this is you can't spend too long open sourcing one thing. Like you can have it as an afterthought thinking like, oh, eventually we'll open source this project and everything will be great. But you probably should do it fairly soon once you decide that, because having a long open sourcing project, many of your premises might not be even true anymore. So, and of course, the reason why I chose Gradle is many different reasons. Gradle is both imperative and declarative. And interesting enough, I got this out of talking with one of the developers on LSDB. Apparently, it's the only correct implementation of Ivy. Ivy itself has a number of problems, caching and otherwise, and using Gradle is significantly better. You can have programmatic control over everything in it. So, in one sentence, the best practice here is to just plan ahead. Cool. All right. Questions? All right, cool. Well, thank you much.